Good day, everyone. Today, we continue with our study with ellipse. This time, let us discuss how to graph an ellipse with center at point HK. Example number 1. Given the equation, quantity x minus 4 squared over 9 plus quantity y minus 3 squared over 25 equals 1, give the coordinates of the center, the foci, vertices, co-vertices, and then graph. Solution? Again, we analyze first the type of equation given. Since the numerators are binomial squares, or in the HK form, we know that its center is not at point 0, 0, but at point HK. Also, since y has the bigger denominator, the orientation of our graph is vertical. Therefore, the center of our ellipse is at point positive 4 and positive 3. Now, how did we get 4 and 3? 4 is the value of our h in the equation. But just like in getting the center of the circle, we take the opposite sign. Since the value of h in the equation is negative 4, that means its actual value is positive 4. The same thing with our k. Since it is negative in the equation, we take its opposite sign. That's why we have positive 3. Again, because a squared is in the y-axis, the orientation of our ellipse will be vertical. Now, let us solve for the length of our semi-major axis, or the value of our a. Since 25 is the bigger denominator, 25 is the value of our a squared. Now, to solve for the value of a, we simply get the square root of both sides. And what is the square root of 25? We have 5. Therefore, the length of our semi-major axis is 5 units. Let us now solve for our b, or the length of our semi-minor axis. Since 9 is the smaller denominator, it is the value of our b squared. Therefore, b squared is equals to 9. Now, to solve for the value of b, we simply get the square root of both sides. And what is the square root of 9? We have 3. Therefore, the length of our semi-minor axis is 3 units. Let us now solve for our c, or our focal length. Substituting the value of our a squared and b squared to our formula. So we have 25 minus 9. And what is the value of 25 minus 9? We have 16. Now, what is the square root of 16? We have 4. Therefore, the value of our c is 4 units. Now, we are ready to locate our vertices, co-vertices, and foci. Now, just as we did with our first example, we start with locating first our center. The x-coordinate is positive 4, and our y-coordinate is positive 3. Locating our center, there you have it. Now, from our center, let us locate our vertices using the value of our a in the vertical direction. There you are. Now notice that since we have moved upward, the value of our x did not change. It is still positive 4. And the value of our y increased 5 units. From 3, it went up to 8. Therefore, the coordinates of vertex 1 is positive 4 and positive 8. Let us now locate the other vertex. There you have it. Again, since we have moved downward, the x-coordinate remains the same. And the value of y this time went down to negative 2. That's because 3 minus 5 is negative 2. Therefore, the coordinates of vertex 2 is positive 4 and negative 2. Let us now locate our co-vertices. Now remember that the co-vertices are always perpendicular to the vertices. It always crosses the major axis. Therefore, their location will be at the left and the right of the center. Now using the value of b, let us move 3 units to the left. So we now have our first co-vertex at point positive 1 and positive 3. Again, notice that from the center, the value of our y-coordinate did not change. And the value of our x-coordinate decreased from positive 4 to positive 1. That's because positive 4 minus 3 is positive 1. Now, for the other co-vertex, let us move 3 units to the right. Therefore, our second co-vertex is at point positive 7 and positive 3. So we simply added 3 units to 4. That's why we have 7. We're almost done now. This time, let us locate our foci. Now, since our focal length is 4 units, or the value of our c is 4 units, we are going to move 4 units from our center. Now, as what we have learned earlier, the foci are always in line with the vertices. Since our vertices are located at the top and below our center, our foci are located likewise. Therefore, counting 4 units, we have our focus at point positive 4 and positive 7. We just added 4 units to our y-coordinate. From 3, we went up to 7. And the value of our x-coordinate remains the same. Now, for our second focus, let us again count 4 units, this time in downward direction. Our second focus, therefore, is at point positive 4 and negative 1. That's because 3 minus 4 from the center is negative 1. Now, we can sketch our ellipse. Let us connect all of the vertices. Presto! You now have the graph of your ellipse. Now, to complete our answer to the problem, since it is asking for the coordinates of the vertices, co-vertices, and the foci, we may also list them all in this manner. So that's it. That's how we graph an ellipse with center at point HK. I hope you were able to follow the steps. In my next video, I will share to you how to transform the equation of ellipse from general form to standard form. So I hope you have already subscribed to my channel so that you'll be notified when I upload my next video. Thank you so much for watching. See you next time. Bye!